So once you know the formula, it's really just an application, very procedural. So, but you do have to identify who the legs are. So this would be A or B, doesn't matter. And the hypotenuse, right? The side opposite the 90-degree angle will always be your hypotenuse, or C. So A squared, B squared equals C squared. Now let's plug them in. So we got 6.5 to the second power plus B squared, which I don't know. And C I do know, 9.9, and we'll raise that to the second power. So 6.5 times, 6.5 to the second power. 42.25. B squared, I don't know. 9.9 to the second power. Oh my God. 9.9 to the second power is 9801. We're going to subtract 42.25 from both sides. And we got B squared equals whatever that is, minus 42.25. And we get 55.76. Now we got to take the square root of both sides. Right, remember, the 2 here, that and that goes away. Makes my B all alone. And take the square root of that side. So we get square root 55.76, which is plus or minus 7.47, but obviously we are not going to use the minus portion of it, so B equals approximately, right, 7.47. 18, hypotenuse, leg and leg. So A squared plus B squared equals C squared. A squared plus 9.7 to the second power equals 13.3 to the second power. So again, understand that it becomes repetitive, right? So 94.09, but because this is your first time seeing this, you might need a little bit of practice. So 176.89. We're looking for one of the legs. Again, we subtract 94.09 from both sides. So minus 94.09 from both sides, and we get 82.8. So A squared. Again, take the square root of that side, then square root of this side. A equals 82.8. Looks like 9 point rounded to nearest tenth. No, rounded to nearest hundredths, 9.10. So that's the value of A. Okay. This one we actually need the hypotenuse, C. So C squared equals A squared plus B squared. C squared equals 5.2 to the second power plus 9.2 to the second power. Good. 5.2 to the second power is 2704. 9.2 to the second power equals 80-something, 84.64. Add those two up. Plus 27.04 equals 111.68. Take the square root of both sides. And 111.68 approximately. I should change that. Plus or minus 3.41 or just 3.42, which is positive value is what we care for. Here, again, we need C. So give them letters. Leg, hypotenuse. C squared equals 2.7 squared plus 6.5 squared. 2.7 to the second power equals 7.29 plus 6.5 to the second power equals 42.25. So we're going to add that plus 7.29 and we get 49.54. C squared, square root of both sides. That goes away. I'm left with C. Take the square root of 49.54. And we get approximately 7.04. Centimeters, inches, I have no idea because there's no units, or just right units. Let's check if it's a triangle. If it's a triangle, left side equals, we can use the Pythagorean theorem to check if it's, both sides are okay. So, draw a triangle. we know this is C, this is A, and this is B. So this is 6.4, this is 12, and this is 12.2. So if you use the Pythagorean theorem, left side should equal right side. So C squared, so 12.2 to the second power should equal the sum of 6.4 squared plus 12 squared. Is that true? No idea. 2 raised to the second power, we get 148 something, 0.84 over here. 6.4 to the second power is 40.96. It doesn't look like it is. 12 squared is 144. If you add these two, come on. If you add these two, left side is 148.84, and the right side is 184.96. So this one is not a right angle triangle. B, again, draw a triangle. Call this 2.1, this is 7.2, and C, our hypotenuse, 7.5. So 7.5 squared, or I'll write this, A squared plus B squared, equals 2.1 squared plus 7.2 squared. See if that's true. 7.5 to the second power is 56.25. 2.1 to the second power is 4.41. There's a decimal there, there's a decimal here. And 7.2 to the second power equals 51.84. As that is up, 51.84 plus 4.41 is 56.25. Oh, look at that. So 6, these measurements for number 6 actually form a right triangle. 7, 7 is the same thing. So again, A, B, C, so let's do 170 to the second power equals square root of 89 to the second power plus 9 to the second power. Well, we know there's a little 2 here. We know there's a little 2, so that 2 and that 2 can go away, so we get 170. That 2 and that 2 goes away, and I'm left with 89, and 9 squared is 81. So, they are. So, these 3 measurements do form the sides of a right angle triangle. This one, again, this is C, this is A, or this is B. B and A can interchange, remember that. So we get 6, A squared plus B squared. Well, C is 15 to the second power. A is 14 to the second power. And B is 2 square root of 26 raised to the second power. Be careful with that. That's 225. 14 squared is 196. And be careful here. Remember when we did powers? Remember, there's a power of 1, right? Here, there's 2 to the first power. So we're still going to do this tree properly here. So that's 2 to the second power. It's going to take us to 4. And that square root of 26, there's a 2 here, the radical, right? So that it's going to cross out, leaving you with 26. Let's multiply those two. That's 104, I think. Yeah, it is. And we're going to add that 104 to 196, which is going to give us 300. So, definitely not a right angle triangle. Not the measurements of a right angle triangle. 11, we got 2 more. So, again, this is C, A, and B. So let's rate everything to the second power. 11 squared, 9 squared, plus 115 to the second power. 11 squared is 121, that's 81, and then 115, radical 115, square root of 115 to the second power. Remember, there's a 2 here. That and that will go away. You're left with 115. Oh. 121 is not the same as 81 plus 115, which is 196, so definitely not the same. Last one, decimals, okay, C squared, A squared plus B squared, so we get, write this down, C, A, and B, 48.5 to the second power, 39 to the second power, plus 32.5 to the second power, 48.5 to the second power is 2,352.25. 39 to the second power is 1,521. And then 32.5 to the second power is 1,056.25. So let's add these together. And no, sorry. They are not the same, so this is definitely these. If you had these three sides, you would not be able to create a right-angled triangle. Find the missing side. Okay, so that's another application for the Pythagorean theorem. Let's see who's missing. The side that's missing, let's call it B. We do have A, so this is C. So 15 squared equals A squared plus, A squared is 4. And B squared. Instead of X, let's call it B. Okay. 225 equals 16 plus B squared. Let's subtract 16 from each side. 225 minus 16 gives us 225 minus 16 gives us 209. And it says leave it in simple radical form, and so we'll get to that in a second. B squared. So take the square root, that 2 and this 2 goes away. So we left with B, and can I simplify? Is that the simplest radical form? 209. No, I can't divide by 3. It's not divisible by 2. 2 times 3 times. I think that's the answer. Can I do the prime factorization of 209? 2, 3, 4, 5, 7. What if I did 7? So 209. I did 4. Hang on. 209. Nope, doesn't work. Nope, doesn't work. Nope, that's fine last. Okay, so radical 209, square root of 29. This one, number 2. So x, let's call it c. So we have c squared equals 5 radical 2 to the second power plus 7 to the second power. Let's call that a or b. C squared equals, and again, think about this, what's happening here is 5 to the second power, which is 25 times, and what happens to the square root when the square root is raised to the second power? It just becomes 2. And then 7 to the second power is 49, so we have 50 plus 49, which is 99. Take the square root of both sides. That goes away, so. And then square root of 99, can we change it to anything? 9 and 11. Yeah, we can change. So if you think about it, we can change that to 9, square root of 9 times square root of 11. Square root of 9, we know what that is. It's 3. Square root of 11 just stays. So that would have been a simplified radical form. This one, again, let's call that c. So we get c squared equals 6 squared plus 11 squared. Let's call that a and b. C squared equals 36 plus 121. 121 plus 36 equals 157. Square root of both sides. C equals square root of 157. Can we change that? 8, 13 is not divisible by 3, not by 2, by 4, no, by 5, by 6, 7, no, 8, 9. No, also that's the final answer. Yeah, I can't do anything with this. 4. Okay, so we want a leg this time around, so let's call that B, and let's call it A, and let's call it C. So it would be 16 squared equals 8 squared plus B squared. That's 144, this is 64, and B squared. minus 64 on both sides. B squared equals 144 minus 64, which is 80. Take square root of both sides. So on the left was B on the right side, and 80, is that the simplest form? Can I change 80 to anything? 4 times 20. 16 times 5, I can do 16 times 5. So 80, I can write it as radical 16 times radical 5. Square root of 16 is 4, and square root of 5, we're just going to leave it as it is. So this would have been my simplified answer. Find the area of each triangle. So I see what you mean. So they're asking you for the area of this triangle. Okay. Now, to find the area of the triangle, as far as today goes, you know that to find the area of the triangle, it's area equals base times height divided by 2. We have the height, but we don't have the complete base. I know from here to here is 4, but that's the base. The base is this whole thing. So I need to find that whole thing. And you can today, because you can focus on this triangle over here, right? The right angle triangle. And in that right angle triangle, this is C, this is A, and this is B. So if you focus on the triangle that I am unable to outline, so if you focus on that triangle, can you find B? Yeah, now you can. You can use a Pythagorean theorem. And once you have find B, you can add it to 4 and get the base of that triangle to find the area. So there's two things we got to do. So let's find B. So C squared equals A squared plus B squared. C is 10, so 10 squared equals 7 squared plus B squared. That's 100. That's 7 times 7 is 49 plus B squared. I'm going to subtract 49 from both sides. We're going to be left with 51 equals B squared. Take the square root of both sides, right? We're left with B and square root of 51. We're actually going to take the square root of 51 here, round it to 7.14. So B, this little part right here, is 7.14. Let me erase everything. Let me erase this. So now I know that that part of the triangle is 7.14, right? Just draw this out. This part right here is 7.14. So what is the whole base of the triangle? So the whole base of the triangle is 11.14 because I have 4 and 7.14. Now can I use base times height divided by 2? Yeah, I have the base. Do I have the height? Yeah, I have the height in the beginning. So base 11.14 times the height, which is 7, divided by 2. And 11.14 times 7, enter, divided by 2, and our area is 38.99. They're units. Choose units squared. Don't forget that's squared. Same thing here. I need the base. I need this whole thing, right? In order to find the area, I need the whole base. I even have the height. Oh, no, I don't have anything here. So, in this triangle, in this part, we can find it. Let's find the height first. Let's call that A, let's call this B, and let's call this C. So, let's find A first. C squared equals A squared plus B squared. A squared equals A squared plus 3.8 to the second power. And we got 64 equals A squared plus 14.44. We got to subtract 14.44 from both sides. 64 minus 14.44. And we get 49.56 equal A squared. So take the square root of both sides. That goes away. We got 2, and A equals 49.56, 56 square root. Clear. 49.56. And we get that A is approximately 7.04. So I'm going to put 7.04 here. I don't know if this is a, now I have to do it again, because I don't know, well, it looks like this is 3.8, so this is going to be 3.8. So now that I have the base, can I find the area of my triangle? Yeah, the base is 3.8 plus 3.8, which is 7.6. So area equals base 7.6, height 7.04, and take all that and divide by 2. 7.6 times 7.04. 4, enter, divide by 2, enter. We get 27 rounded, 0.7, 25, 26, sorry. We get 26.75 units squared. That's the area of this triangle right here. So area equals 26.75 units squared. Okay, so that was that.